FireEye is pleased to announce that we now offer our FX series of servos for sale at 19.2 kilobaud for general use in PLC applications. Now, the FX series of servos is the servos that we use with our PPC and NXF 4000 parallel positioning systems. They run at 24 volts DC and have 110 angular degrees of travel available. So this model is the FX20, and this is a 20 Newton meter or 15 foot-pound model. And this is a -19 variety, so FX20-19, and it has conduit entry. It has 2 conduit entries so that you can daisy chain one servo to the next, and it runs on 24 volt DC at 35 watts. Now we also have the FX4, and this is a -119 variety. The extra one indicates that it has the quick disconnect. It's a 5-pin, and it uses a pre-made cable assembly that you can thread on like so to be able to quickly disconnect the servo as needed. And this is a 4 Newton meter or 3 foot-pound variety, also 24 volts DC at 7.5 watts. There's also a FX50, which is a 50 Newton meter or 37 foot-pound variety running at 38 watts of power at 24 volts DC. So here's the FX20-19 with the cover off. This allows us to configure the address, which is set using this rotary dial. So we can choose the address between 1 and 9. Right now it's set to 1. Or we can choose 0, which corresponds to address 10. The baud rate is fixed at 19.2. The rest of the communication settings are 8 data bits, no parity, and 1 stop bit. And here's the terminal designations. First we have the ground terminal, and this is outlined in our NEX-3001 bulletin as well on our website. We have the power connection here, and we have the Modbus connection here. And each of these connections has 2 terminals to allow you to daisy chain in the proper serial manner between multiple servos. We also have a couple of buttons here, clockwise and counterclockwise buttons, that allow us to manually move the servo as needed. This is great for when you're setting it up, when you're connecting it to a coupling arm or something, so that you can test and make sure that the drive is correct and everything before you start driving it with Modbus. So the PLC I'm connecting it to is a Micrologix 1400. I'm using channel 0, which is the COM port on the bottom. It's a RS-485 and 232 combined port. It uses a mini DIN 8 connector. So I've made my own connection cable using a mini DIN 8 serial cable cut in half so I can get the leads I need off of it. It uses pins 1 and 8 for the Modbus connection. Pin 8 is the minus and pin 1 is the plus, and it uses pin 2 for the ground. So here is my PLC program that I have running to control the 19.2K FX20 servo. This is actually the FX20-19 servo, since it's the 19.2K baud rate version. So this simple program is just sending a read and a write message via Modbus, and I'm also putting on the little LCD screen on the Micrologix 1400 the data so that I can read the position and set the position. So if I go look at my I/O channel, channel 0 is for Modbus. I have it set up as a Modbus RTU master, 19.2K baud, and no handshaking 485 to indicate I'm using RS-485 here on the first message. And all of this information is in the bulletin, NEX-3001, available on our website, www.fireeye.com. This explains how the Modbus communication works. So right here I have a 06 function, write single register, and I am writing to address 62, 40062, which translates to 61 in a zero-based addressing scheme. And that lets me drive the servo at its fastest rate of 30 seconds. The speed depends upon the address that you choose to write the command to. So if I wrote this command to address 2, the servo would drive at its slowest speed. So I have the addresses between 2 and 61 to choose from, scaling towards faster as you go up. So I'm writing to that address, I'm writing the contents of N7:0, and then for the read, I am reading the address 62 as well, and you can actually read any address you want. This allows you to do a read with a write or write with a read verification, sorry, and so that you can read from the same address you write. But in actuality, you can read from any address that's valid, in other words, any address from 0 to 61, and you can read from 1 to 6 registers, and the reply in the order of registers indicates the commanded position, the actual position, etc. And again, this is all explained in the NEX 3001 bulletin very clearly. So with this Modbus command, this read command, I am reading just 2 registers, which is the commanded position and the actual position. And then in the rest of the logic, I am just transmitting the integer result to a float, so I can divide it by 10 because the numbers in Modbus come in with a resolution times 10, so a value of 100 would equal 10.0 angular degrees. So on the LCD screen I want to show it with the decimal, so I'm transferring it over to a float, and then here I write it to the LCD screen on the MicroLogix 1400. So here is the application running. This is a simple application. It just uses the LCD display to show the current position with decimal accuracy of tenths, and as well as allowing you to put in a new position for the servo motor. So right now, showing a position of 22.5 degrees, and the go-to is times 10, so you have to multiply it by 10. So if I want to go to 450, which is 45 degrees, I just use the arrows here. I can drive the servo to 45 degrees. Hit OK, and it will drive, and the feedback will show me the position as it moves. Something else we got here to make sure that it's working, we have this little light here, COM0, that's for serial port 0, channel 0, the one we're connected to. If that blinks, that means you have active Modbus communication. Thanks for watching, and I hope you guys enjoy using the new FX series servos with your PLC application.